Hey guys, so first off, if you were not here or if you didn't hear me make this correction, that should be a 12x in number 1, not a 12y. Okay? Alright. I erased it because I started working it the other day, but then I thought, oh, okay, I'll just go ahead and make a video using this. So, anyway, parabolas. If you've got y squared, that means it's a left-right parabola, and if you've got a positive 4p, then that means it opens to the right. So, if I were to graph an x and a y, I know that the vertex of my parabola is, well, with the x, you can think of it as -0. There is no term there, so it's 0. And then the y, opposite of -4, would be +4. So it's 0, 4. Okay. Okay. In the formula, well, just as a reminder, x minus h quantity squared equals 4p times y minus k, or y minus k and then x minus h. Either way, you've got 4p, which is 4 times the focal length, and the focal length is the distance between vertex and focus. So since this is my vertex and I'm opening to the right, in order to get to my focus, I have to travel to the right. Okay, and in fact, I set 4p equal to what's right there, 12, which means my focal length is 3. So in order to get to my focus, I have to go 3 units to the right, which makes my focus the coordinate point 3, 4. And then the focal length is the same to get to the focus and to the directrix. So that means I have to go to the left 3 to get to my focus or to my directrix. But it's not a coordinate point, it's a line, right? So the directrix is actually x equals -3. All right? And then focal width is absolute value of 4 times p. And we have that right there, so that's just 12. Okay. Number 2. This has an x squared, which means it opens up, down, and since it's negative right here, that means it opens down. So I know my vertex is the coordinate point -2, opposite of +2, and +8. So it's left 2, up 8, left 2, up 8, and I know it opens down. Okay, so whenever I go to get to my focus, I know I'm going to go down, so I'm going to stay on the line x equals -2. And in order to find my focal length, I'm going to set 4p equal to -34. So divide by 4. 34 does not divide by 4, but it is even, so I could say -17 halves. And I could go ahead and put that in decimal form. 16 halves is 8, so 17 halves is -8.5. So if you want to think, okay, 8 minus 8.5 will put me in -0.5. The other option is you can say the y value 8 minus 17 halves. And so 8 is 16 halves, and that is -1/2. So either way, you get to -0.5. I'm going to go and put -1/2 just because. Okay, it does open down, so in order to get to my focus, I have to go down 17 halves, but that means in order to get to my directrix, I have to go up 17 halves. So I'm actually going to change that. 8 plus 17 halves is 16 halves plus 17 halves, and that is 33 halves. And 33 halves would be, let's see, 30 halves is 15, 32 is 16, so 16.5, which makes sense if you take 8 and you add 8.5. I don't know why I just wrote 8 plus 5. So if you go up 8.5, you end up at 16.5 or 33 halves. Okay, now your directrix is a horizontal line, so it is the equation y equals 33 halves. Or, 16.5. Okay. Focal width is a positive 34 because remember focal width is always positive. All right. Number 3. This is an x squared situation, which means up, down, and 44 is positive, which means up. So my vertex, so for the x, it is right 7, and for the y, it is down 4. So right 7, down 4. 1, 2, 3, 4, 5, 6, 7. and down 4. And I know it opens up, which means to me I need to go up to get to my focus and down to get to my directrix. So I just got to figure out what the focal length is. 4 times what gives me 44, and that is 11. So that means if I go up 11, negative 4 plus 11, that puts me at 7. If you wanted to count it out, you could, but negative 4 plus 11 is 7. So I know that I'm up here at 7, 11 in order to get to my focus. And in order to get to my directrix, I have to go down 11. So that was, what did I just say? No, I need to go up 11. Puts me at 7. Up 11 puts me at 7. That's silly. And down 11 puts me at negative 15. So it is a horizontal line, which puts me at y equals negative 15. Okay, and then focal width is again 4p, which is just a positive 44. Okay, number 4. We've got y plus 8 quantity squared, which means a left-right situation, and because it's a negative right here, that means go left. So my vertex is x first, negative 9, then y, negative 8. So left 9, down 8, and we're opening left. Interesting. 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8. And we're opening to the left. So if that's my vertex and I need to open to the left, that means I need to go to the left to get to my focus and to the right to get to my directrix. So to figure it out, I set 4p equal to negative 14, which means my focal length is negative 14 fourths or negative 7 halves, which is negative 3.5. So if you just want to go left 3.5 from negative 9, that's fine. Or you could take negative 9 and subtract 7 halves. And 9 is 18 halves. Just change it to a positive. So 18 halves minus 7 halves is negative 18 halves minus 7 halves is negative 25 halves, which is negative 12.5, which is the same thing as negative 9 minus 3.5. So my focus is at the point negative 25 halves, comma, y value stays the same, negative 8. Or like I said, you can say negative 12.5. The directrix, I need to go to the right 3.5. So to the right 3.5 would put me at 5.5. And then the other option is I add 7 halves because I'm going to the right. And that would be, 9. 9, which is 18 halves. So that puts me at negative 11 halves, which is negative 5.5. So 1, 2, 3, 4, 5.5. It would be here. So you could put x equals negative 5.5 or x equals negative 11 halves. Focal width, positive 14. All right. Number 5. Use the information provided to write the vertex forming the equation of each parabola. So I know that my vertex is at to the right and down, and my focus is to the right and stays there. So to the right 4, down 3 to get to my vertex, and my focus is at 4, 0, which tells me if my focus is here and my vertex is there, I've got to open up around it. So I know so far that it is x being squared, and my vertex is 4, so at 4 for x, so minus 4, and negative 3 for y, so plus 3. And then the distance between my vertex and my focus is 3, so that's just 3 times 4, which is 12. And then my directrix, if I go up 3 to get to my focus and I go down 3 to get to my directrix, which would put me at negative 6. And there's a horizontal line, so y equals negative 6. All right, number 6. My vertex is at 11, 7, and my directrix is at x equals negative 1. So 11, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. My vertex is there. And my directrix is -1. X equals, which is a vertical line. It really messes you up whenever you get the vertical and horizontal switched. So because my directrix is vertical and my vertex is on this side of it, I know I have to open to the right. Okay. I also know that, I'm going to have to put my equation down here then. If I open to the right, that means that it's y being squared. So I'll go ahead and put y and then x. I know my vertex is 11, 7, so x minus 11 and y minus 7. And then 4 times my focal length. Well, the distance between -1 and +11 is 12, which means my focal length is 12. And so it's 4 times 12, which is 48. And then my focus, so if I go 12 to the left to get there, I go 12 to the right, and 11 plus 12 is 23. So we're talking about a coordinate point way over here at x equals 23, but the y value would stay the same, 7. Okay. Number 7. Number 7, we've got a vertex at -5, 0. It opens down and has a focal width of 9. So left 5 stays there. Opens down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And that's my vertex. The fact that it opens down tells me that it is x being squared and y not. Okay. So the x value is -5, so +5. The y value is 0, so you could put, well, in fact, you could put y minus 0, y plus 0, it doesn't really matter. I'm just going to put y. And then my focal width is 9, so, okay. I could just put a 9 there. I do have to remember, though, that it opens down, so that's a -9. As far as finding my directrix, though, I actually should have written down focus as well, because that's something I would potentially want you to find. If your focal width is 9, then 9 equals 4p, which means p equals 9/4. And 9/4 is 2 1/4, 2.25. So you could say, okay, go down 2.25 to get to your focus, and go up 2.25 to get to your directrix. And you can do that in decimal form, or you can leave it as the fraction, because we're at the y value 0 right now, which is kind of convenient. So to go down, I would go down 9/4 to get to my focus, which is the coordinate point, -5, -9/4. And to go up, I would go up 9/4 to get to my directrix. Horizontal line, y equals 9/4, or 2.25. Okay. The test is going to be non-calculator, or the quiz, which is why I'm fine with you guys putting in decimal form if you're more comfortable with that. The focus is at 2, -6. It opens left, and there are 5 units between the focus and directrix. Okay, so 2, -6. So I need to be able to see 1, 2, 3, 4, 5, 6, and that is my focus. And I know it opens to the left, which means it has to open up around that, which means my directrix is over here. If it has to open to the left, that means it tells me it's y being squared. Okay. There are 5 units between the focus and the directrix. So, okay, if I know it opens to the left, if I go 5 units, 1, 2, 3, 4, 5, which puts me at 7, then that is where my directrix should be, at x equals 7. Yeah, and then my vertex has to land right in between those, so halfway between 2 and 5, or 2 and 7 is 5.5, right? Or 4.5? Yeah, 4.5. The distance between 2 and 7 is 5. And so half of that would be 5/2, which makes 5/2 my focal length p. So I could take 2 and add 5/2 to get to my vertex, or I could take 7 and subtract 5/2 out of the way. 2 is 4 halves, which puts me at 9 halves. Or you can say go forward 2.5, which puts you at 1, 2, 4.5. Or 9 halves to get to your vertex. So my vertex is the coordinate point -6. Sorry, that's a y value. That's bad. 9 halves, comma -6, which makes this +6 minus 9 halves, or minus 4.5. And then right here we get, you get 4 times this, so 4 times 5 divided by 2. Or you can say if, 5 units between is 2 times p, so then 2 times that is 10. But either way, 4 times 5 halves is 2 times 5, which is 10. And we open to the left, which means I need to make sure to make that negative. Okay. I guess I should say that p is negative whenever you go to the left or down the focal length. Okay, number 9. My focus is at 6, -3, and my directrix is the horizontal line y equals 2. So 6, -3. Wow, that was annoying. Leave some space for my equation. So 1, 2, 3, 4, 5, 6. 1, 2, 3. So that's my focus. And my directrix is at y equals 2, which is a horizontal line at 2. Okay? So if my directrix is here and my focus is here, and I have to open up around my focus, that means I'm opening down, which means it's an x something squared equals, I'm going to go ahead and put the negative there just so I don't forget, and then y. And a negative because we're opening down. This right here is a distance of 5 between them, which is just like the last one. So if I'm 5 is halfway between, or 5 units between directrix and focus means 5 halves unit between focus and vertex, or directrix and vertex. So if I go down 1, 2.5, puts me at -1/2, or you could say -3 plus 5 halves, or you can say 2 minus 5 halves. Either way, you get to the same thing. -1/2. So my vertex is the coordinate point 6, -1/2. So x minus 6, y plus 1/2. And then if, again, if my focal length is -5 halves, then 4 times that would be -10. Okay, number 10. My focus is 1, 5, so over 1, up 5, it opens left, and so, well, there you go, 1, 2, 3, 4, 5. That is my focus. I open left, and my focal width is 10. So if I open left, that means I have to go to the right to get to my vertex, and then to the right further to get to my directrix. So, I'm going to post that one down. Okay, so if my focal width is 10, well, dadgum, I did that 3 times in a row, same thing. It's kind of boring. Oh well, whatever. 4p equals 10, so p equals 5 halves again, which means I'm going to go to the right 5 halves. 1 plus 5 halves. 1 is 2 halves. So 2 halves plus 5 halves is 7 halves, or 3.5. 1, 2, 3. 1, 2, 3. Let's go 3 here, and then that would be 7 halves. That would be my vertex. And then in order to get to my, well, I'll go ahead and write that down. The vertex is at 7 halves, comma 5, same y value. And then to get the directrix, you would add another 5 halves. So 7 halves plus 5 halves gives you 12 halves, which gives you 6. Okay? Also, I could just use the focal width as 10, so I go from, well, no, yeah, 5. It was just half. Well, never mind. Okay. So to get to there, I go to 6. So it's 3, 4, 5. 6. Okay. And that is a vertical line, x equals. Because it opens left, I know it's y quantity squared equals, it's negative x something, it's negative 10 because focal width is 10. Sorry. And the equation for the vertex, I've got 7 halves and 5, so y minus 5, y value with y value, x minus 7 halves. All right. Number 11. Sketch the graph of the parabola without the use of a calculator. Plot and state the vertex and focus on directions and use the focal width and plot 2 or more points to create the parabola. Write the coordinates for the 2 points. So what I know is that my x value of my vertex is negative 2 and the y value is negative 3. So I'm going to go ahead and plot those, negative 2, negative 3. I know because it's y quantity squared, it opens left, right, and because it's positive, it opens to the right. So I know I'm going to go to the right to get to my focus, because this is my vertex. So if 4p equals 9, then p equals 9/4, which is 2.25 again. So if I were to take negative 2 and add 9/4, and find a common denominator, multiply by 4. Negative 2 times 4 is negative 8, so negative 8/4 plus 9/4 is 1/4. So if I ever go to the right 9/4, I would end up at 1/4 to be at my focus. So my focus is the coordinate point 1/4, comma, negative 2. Okay, to get to my directrix, I would go in the opposite direction. So I would say negative 8/4 minus 9/4, which is negative 17/4. Or negative 2 and then backwards 2.25. So 1, 2.25, which puts me at negative 4.25, which is what that is. And that is a vertical line. So directrix, I'd like it labeled somewhere. X equals negative 17/4, so negative 4.25. But if you label it on the graph, that's okay. If you were to put x equals negative 17/4. Okay, I need 2 more points from you. So I said use the focal width. The focal width is 9, which means 9 on either, 9 total across the parabola through the focus. So that means go half of 9, which is 4.5 in each direction. 1, 2, 3, 4. So 1, 2, 3, 4.5. So if you wanted to do that, you could, or if you wanted to figure out the decimal, because I did ask you to plot, tell me what those points are. You could take the y value, which is negative 3, and add 9 halves. So if you take that, negative 3 is negative 6 halves, common denominator, and that is positive 3 halves, or 1.5. So the x value is still just a quarter, and the y value is 3 halves. And then if I go down the same amount, 1, 2, 3, 4.5, I could say negative 3 minus 9 halves. So negative 3 over 1, so, which is negative 6 halves. So negative 6 halves, negative 15 halves. So it's still 1/4, but now it's negative 15 halves, which is negative 7.5. Okay, and then plot the parabola. So it looks something, oop, just kidding. Something like that. And you don't need to keep going because that's too many random points that we're just assuming. It's not so much more. I will. Okay. Number 12. Write an equation for the parabola shown using the 2 points indicated. Okay. I know the vertex is 3, 2. So 1, 2, 3, and then 2. That's my vertex. And it goes through the point 1598. Should probably have given you a little bit more information than that. We'll figure it out. Well, we kind of do need to know which direction it opens. That was poor planning on my part. If you have a question like this on the test, I'll tell you which direction you open. Okay, we're on the quiz. So 1598, we're going to go ahead and say you open up. We're going to have to go with that. Okay. X quantity squared equals 4p times y something. So my vertex is 3, 2, so x minus 3, y minus 2. And then I'm telling you that you go through the point 1598. So what I would do is I would take the x value and replace it with 15, and the y value and replace it with 98, and solve for the value of p that makes it true. Okay, so technically anything you did you could make it work. I mean, you couldn't make it open down, and you couldn't make it open left, but right and up would be valid options, which might not be pretty. So 15 minus 3 is 12, and 12 squared is 144. And then 98 minus 2 is 96. And the quiz will be non-calculator, but that would mean that I wouldn't give you numbers like this. So if I divide 144 by 96, I get 1.5. So that means 4p equals 3 halves, which is 1.5. So I can either just use that, or if you weren't thinking about it, you could divide by 4 and 96. 4 times 96. Just be careful about doing that. If you divide by 4 times 96, technically you only divide it by 4, and then you multiply the answer. So that means you need to put parentheses. Okay? But either way, I know that my equation is going to be x minus 3 quantity squared equals 3 halves times y minus 2. And there we go. All right, let's go to ellipses. A little bit more fun. Okay. So for this one, I know that this is over 1, which tells me that a equals, well, let's say a squared. A squared is 49, b squared is 1. A squared always has to be the larger denominator, okay? Which means that my y-axis is my major axis, okay? It also doesn't have x plus and y plus or minus, which means my center is at 0, 0. Okay. So if my major axis is vertical and a squared is 49, that means a is 7. So I'm going to go up 7 and down 7 to get to my major vertices. And if b squared is 1, that means b equals 1. So I'm going to go left 1 and right 1 to get to my minor vertices. And so the only thing I still need to find are the foci. So I know that the relationship between these a, b, and c is that a squared equals b squared plus c squared. A is the largest of the 3 lengths. And I'm going to go ahead and use these numbers right here. 49 equals 1 plus c squared, which means c squared equals 48, which means c equals the square root of 48. Now on your quiz, I'm going to have you graph, but I will not expect you to sketch the foci if they're going to be a square root, okay? So I would expect you to sketch the major, minor, and center, but as far as the foci, if it's a square root, I can't expect that without a calculator. So, although I could expect you to know that it's pretty close to 7. So if the foci are at 6.9 for all intents and purposes, then that would be right here and right here. Yeah, they would land right up on it. So my foci would be the coordinate. Well, I guess we gotta label these things, so write them down. Center 0, 0. Major vertices would be 0 plus and minus 7. Minor would be plus and minus 1. And then my foci would be at 0 plus and minus the square root of 48, or 16 times 3, so 4 root 3, plus and minus that. And then to sketch it, I do have to draw some kind of oval elliptical shape as much as possible. Okay. Number 14. So number 14, I've got a center at -1/2, comma 0. So the y value doesn't have one. So I'm going to go left 1/2 and up none, which is kind of boring. I'll do it again. Okay. Sorry, every once in a while my screen goes down. Okay. And then I've got 36 and 25, which means my a squared equals 36 and b squared equals 25, which means a equals 6 and b equals 5. So from my vertex, I'm going to go, since 36, since a squared is underneath the x, that means my major axis is horizontal. So I'm going to go 6 left and right. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, so my major vertices are -6.5, which is -13/2, and +5.5, which is 11/2. And then my minor. So it does say to go, b squared is 25, which means go up and down 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Which means my minor vertices are -1/2, comma 5, and -1/2, comma -5. And for my foci, I know that C is the square root of b squared. Sorry, a squared minus b squared. So C is the square root of 36 minus 25, which is the square root of 11. So my foci, I go left and right, square root of 11, because that's my major axis. So I could just say, because I don't know what the decimal is, -1/2 plus and minus the square root of 11. So that means take your center right here, -1/2, and go left and right the square root of 11, and don't change anything on the y, right? So if I wanted to plot those, I could, but like I said, I wouldn't expect you to do it on the calculator or on the test if it was a square root. So -0.5 plus the square root of 11, 2.81. So that would put me at here-ish, and then I got that right, yeah? Oh, heck, I'm at the wrong side. Let's say what? 2.8, and then -1/2 minus. And that would put me at -3.8. Okay? And then you would do some kind of sketch. Oh, this is not going to be good. Oof, it's looking like a football. Oh, well, it is what it is. Okay. Not perfect at all. Okay, so number 15. Use the information provided to write the standard form of the equation of each ellipse. All right. I know that I have vertices at 0, 8, and 0, -8. So that does, for this, it implies major when it just says vertices, and it implies minor when it says covertices. So 0, 8, and 0, -8. 8 and -8, which tells me that A equals 8 and a squared is 64. Okay, and if my major axis is vertical, then that means that a squared goes underneath the y. So that means 64 goes underneath the y. Now, halfway between my vertices has to be my center, which means my center has to be the coordinate point 0, 0, which means no additions, subtractions. So there's x squared and y squared. Okay. The foci are at 0, plus and minus 4 root 3. So that means I would go up 4 root 3 and down 4 root 3 to get to my foci, which means obviously the horizontal is my minor axis again. But I got to figure out what B is. So if I know C is the 4 square roots of 3, there's a couple different ways to do this. You got to figure out what C squared is, which is 4 square roots of 3 squared. So you could say 4 squared times the square root of 3 squared, which is 16 times 3, 48. Or you can bring the 4 in as 16, and 16 times 3 is 48. And so it's just the square root of 48 squared. Whatever speaks to you. Either way, C squared is 48. So if I know that A squared is 64 and C squared is 48, and A squared equals B squared plus C squared, then B squared equals A squared minus C squared. So 48 to 60 is 12, so 16. So that means B squared is 16. So if I needed to graph it, I could, I know B squared is 16, which means B is 4, so I could go left 4 and right 4. And there you go. All right, number 16. So I've got, if you'll notice that it says 5 and then negative 10, 5 and then negative 10, and then the only thing I'm changing is I'm adding and subtracting the square root of 69 to 5 to get to my foci. That leads me to believe that my center is at 5, negative 10. Now I could also figure that out just by using this. My co-vertices are my minor axis. My minor vertices are at 5, 0, and 5, negative, 5, 0, and 5, negative 20. So 5, 0, and 5, negative 20. Which makes sense why then my center would be at 5, negative 10. Yeah? And if this is my minor axis, vertical, that means my horizontal, again, is my major. So if I know my center is 5, negative 10, then I go ahead and start writing my equation. X, y, x minus 5, y plus 10. And I know that my minor axis has a total length of 20, which means B is 10. Which means if minor is vertical, then that means 10 squared, so 100 goes there. Okay? Now I also know that to get to my foci, I go 5 plus the square root of 69, negative 10, and 5 minus the square root of 69. Now I know that the square root of 69 is a little bit larger than the square root of 64, which is 8. So all I know, or all I really need to know, is that C is the square root of 69, the focal length, the distance from center to foci. And that means C squared is 69. And I know that I'm trying to find A squared, right? A squared equals B squared plus C squared, which means A squared equals B squared, 100, plus C squared, 69. So that's 169. And there you go. All right, number 17. My center is at 3, 6. So if I go to the right, 3, and up 6, 1, 2, 3, 4, 5, 6. I get to my center. I have 2 foci at 3, 8, which puts me here. If that's my center, and that's one of my foci, that tells me that C, the distance from center to foci, is 2. And if I go down 2, I get to my other foci, which also tells me that the vertical is my major axis. So this gets A, whatever A squared ends up being. My center is 3, 6, so minus 3 minus 6. I know that C is 2, and I also know that the length of my minor axis is 7. So when they say length of minor axis, they mean all the way across. Okay? So that means B is only 7 halves, which is interesting. that means that b squared is 49/4. Okay, so if that goes here, 49/4, although if I were to rewrite it, then I would, because I don't like fractions within fractions, I would put the 4 up top. So I'd say 4 times x minus 3 squared over 49. Not likely to happen on the quiz, though, since we didn't practice that on homework. And then I need to find a squared. So if I know c squared is 4, and I know b squared is 49, and I know a squared is b squared plus c squared, then I could say that a squared equals b squared plus c squared. 4 over 1 times 4 times 4, which is 16. So then I could say 50, 65. 65/4, which would mean 4 times 1 minus 6 squared over 65 equals 1. Yeah, that was a little interesting. I probably wouldn't put it on the I know I didn't put it on the quiz, so don't really need to worry about the decimal aspect of it, but you do need to be able to find the other points, or find A, B, and C, whatever you need. If you did want to go thinking about the length of 7, that means you go left 3.5 and go right 3.5, so you know you'd be at 6.5 and negative 0.5. In order to, where's my center. And that would be your other endpoints. And then your major would be up and down here and there. Okay. Number 18. I have a center at negative 10, negative 8, negative 17, negative 8. Okay, so I need to see this quadrant. I have these two. Mainly this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17. And then down 8. 1, 2, 3, 4, 5, 6, 7, 8. So I know my center is at negative 10, negative 8. And I know one of my vertices is at negative 17, negative 8. And then I also know my focus, one of my foci, are at negative 10 minus the square root of 13, negative 8. So square root of 13 is a little bit more than the square root of 9, less than the square root of 16. So it's 3 point something, which puts me at 13 point something. 11, 12, 13 point something. So my foci, we're just going to pretend is there. That's one of my vertices, and then this is my center, which tells me basically everything I need to know. I know that my horizontal is my major axis. I also know that A is the distance between here and there, vertex and center, so A is 7. So that means A squared is 49. And that is horizontal, so that goes underneath the first one, X. I know my center is negative 10, negative 9, so plus 10, negative 10, negative 8, so plus 8. And I also know that if A is 7, then A squared is 49, and I know that C, the distance between center and focus, is the square root of 13, which means C squared equals 13. So A squared equals B squared plus C squared, which means 49 minus 13 equals B squared. And 49 minus 13 is 36. Yep. And that's B squared. And there's my equation. And I do believe that is it.